All right, now, when we did lesson 2-4 day 1 homework, we had to multiply some binomial structures with i's in them. And this type of structure showed up. Let me show you what we did. We had something like this. 4 plus 3i times 4 minus 3i. I don't know if that's an exact problem, but you had problems looking like that. You had a binomial complex number, real plus imaginary, being multiplied by another binomial complex number, real plus imaginary, or minus imaginary in this case. All right? And anytime you're multiplying binomials in math, you do either FOIL or some form of the distributive property. The main idea is that you're going to multiply this number times both of these numbers, and you're going to multiply this number times both of these numbers. That's the main idea. Whatever technique you do to multiply that out, that's what's happening to multiply that out. So if I do those multiplications, watch what happens. 4 times 4 is positive 16. 4 times negative 3i is negative 12i. Then I do the green multiplications. Positive 3i times positive 4 makes positive 12i. And positive 3i times negative 3i makes negative 9i squared. Okay. So that's what you get by multiplying the structures, right? So the 4 plus 3i and the 4 minus 3i, you multiply them out and you get these four products. And two things happen that you should notice. The first thing you should notice is that this object and this object, the two I objects, are opposites, right? Negative 12i and positive 12i are opposites. They combine to make 0i, better known as 0. In other words, they cancel. So for that, those go away. The other thing you're going to notice, hopefully, is this has an I squared on it. And just like the last frame back here, I squared equals negative 1. This is always true. All right? So if I squared is negative 1, all of a sudden I've got, instead of 16 minus 9i squared, I've got 16 and then minus 9 times negative 1. Because I squared is negative 1. And then minus 9 times minus 1 makes plus 9. And 16 plus 9 is 25.
Oh, I forgot that part.
All right? And all of a sudden, notice we multiply these two things together and we got a real number out of it. Okay? And what you were supposed to see was how to do that technique. That's what 2-4 day 1 is about. So that on 2-4 day 2, when I'm talking about it, I'm going to let you know something very important. This is not coincidental. When I multiply these structures just like this, getting a real number always happens. And here's the thing that makes it happen. Okay? What I've made here when I multiply these two things together is I have a complex number, 4 plus 3i. And the other complex number here is called the complex conjugate. Okay, don't worry about the name of it so much as knowing how to make it. But again, if they discuss about complex conjugates in your homework, that's what this is. Complex conjugate. If you get a binomial denominator like we have here, you're going to have to be able to make a complex conjugate to fix it. Right? Here's how you make a complex conjugate. Very simple. You create an object with the exact same two pieces. This has 4, this has 4. This has 3i, this has 3i. The second object changes sign. That's it. That's how you make a complex conjugate. When you have a complex conjugate, this always happens. You get a real number.
So if we did that on this example, it'd be 10 and 2?
No, it's just looking at the denominator. So we're looking at this only. And I'm looking at that binomial structure right there, and I'm asking myself, what two objects are there? And the two objects are 2 and I, right? But then this is minus, I want this to be plus. Right? Because again, the issue here, and any of these imaginary numbers in denominators, that's illegal. This is not allowed to happen. We're not allowed to have i's in the denominator of a fraction. Okay, we need them to be in the numerator only. Denominator i's are hard to work with and can't be used very easily. So, if you have an I in the denominator and it's part of a binomial structure, two objects, rewrite the structure with the opposite sign in the middle. And again, fraction world, when you multiply the bottom by something, you got to multiply the top by the same something. So once you've established this is what I need to multiply the top by the same thing.
So,
Can't those cancel
Yeah,
out?
well, we're gonna have to multiply it out now. So, and be careful that, and what Alicia just said, or sorry, Alexis just said about canceling stuff out, right? What we're doing, and again, this is kind of the same structure, we had to FOIL this basically, or do distributed property, we're gonna do that. We're gonna simplify using FOIL or distributed property. So, using the same color scheme. I got my first object 2, I'm gonna multiply by both these objects. So this is just the denominator, I'll worry about the numerator in a moment. So here's my fraction bar here. And in the denominator, I'm gonna multiply 2 times 2 makes positive 4, 2 times positive I makes positive 2I. And then I'm gonna multiply negative I times both of these things. Negative I times 2 makes negative 2I. And negative I times positive I makes negative 1I squared, or just negative I squared if you wish.
so we put that all on the bottom.
All on the bottom, because again, that's what that multiplies out to. There's going to be 4 products there all together. You get them all on the bottom.
Alright.
So, again, what you should expect to happen every single time, notice those two guys are opposites. That's not coincidental, it's supposed to happen. Okay, if that didn't happen, you probably have a sign wrong. So be careful, make sure that those are opposites, they should go away. You should be left with a real number and an I squared, which is negative 1. So, this part here becomes minus negative 1. So the minus I squared goes away, we replace it with minus negative 1. And then the bottom, if I continue the bottom one more step here, it's just 4 and minus minus means plus plus, right? So 4 plus 1 is 5. So the bottom is 5. Real.
So plus plus equals 1.
Yep, so it's minus minus 1, which is plus plus 1. 4 plus 1 makes 5, right? So again, you have this real number 4 over here already. You're just going to either add or subtract this based on whatever happens to the signs. On top, kind of been ignoring the top here recently, we have 10 all by itself, one single object being multiplied by 2 plus I. So 10 times 2 makes 20. 10 times I makes 10I. Right? Positive 10, positive 2 makes positive 20. Positive 10, positive I makes positive 10I. And notice this time the real number's in front, the imaginary is back. So again, each problem has its own little personality to it. You're going to get what you get where they're at. But that's what the top simplifies to, and I can't make that any prettier, so I'm going to keep it 20 plus 10I right here. So as you're simplifying part of it, get the other one to come along for the ride. And then the final thing again is to separate this into 2 separate fractions, a real fraction, 20 over 5, added to an imaginary fraction, 10 over 5. So I'm going to get 20 over 5 plus 10I over 5. The real fraction in front, the imaginary fraction in the back. And I want to reduce if possible. Whole numbers are better than fractions if you can make them happen. Reduced fractions are better than non-reduced fractions if you can make that happen. 20 divided by 5 is 4. 10I divided by 5 is 2I. So 4 plus 2I is equivalent to 10 over 2 minus I. Again, that's our task in the problems today, to make an equivalent expression in A plus BI form.